All right, rewriting. Literally, you can use one section to help you with the other, okay? You're just, for first and second section, you're literally going from one to the other. So if it wants you to rewrite an exponential form, then your answer should have exponents. The base of the log is the base of the exponent. The answer for a log is actually the exponent. That's what you're solving for when you find a log. So here, the 3 is going to be the exponent. And then the answer, 2 cubed, is going to equal 8. So you're literally just writing it. The base of the log is the base of the exponent. Your answer of the log is the exponent. And then what you're taking the log of becomes your answer. So then the other way is the same thing. The base of the exponent becomes the base of the log. The answer of the exponent is what you're taking the log of. And the answer of the log is the exponent itself. So then when you evaluate these, you can actually set these equal to x and rewrite them in exponential form. You can say the base, 2 to the power x equals 1 over 16. Anytime you have a fraction as your answer here and you're trying to find the exponent, your exponent is going to be negative. Anytime you go from a larger number to a smaller number, not a fraction, then you're going to have a root, some type of radical, right? So in this case, it's in the denominator, it's going to be a negative. 2 to what power equals 16, and then make that a negative. So if you're looking at 2 to the power, that's 2 to the 4th is going to equal 16. But because the 16 is in the denominator, your exponent here is going to be negative 4. So if you are going from a whole number to a fraction, 1 over a number, that's going to be a negative exponent. A number to a number smaller, like if you look at number 12, from 9 to 3, that's going to be a fractional because that's a root. The square root of 9 equals 3. So that is 9 to the 1/2. So like I mentioned earlier, these will just be together in one set of questions. So if it gives you a number of times a year that something compounds, that's going to be your first equation. And for that one, you would have your investment return is going to equal your principal times 1 plus your rate over the number of times that it compounds annually, raised to the nt, and still the same number of times it compounds annually, and t the number of years. So in this case, A is what I'm solving for. What is the account balance? They have given me principal of $2,982. 1 plus my rate 2%, you want that as a decimal. Number of times a year it compounds, 3, raised to that 3 again, times that 5. All right, you can do all of this at one time in your calculator. All right, just make sure you use parentheses around that group, and that when you raise it to a power, you either go ahead and type in the 15 or you put parentheses in that power as well. Because if not, some of them will drop out of the power and multiply your whole answer times 5, which would be not correct. All right. So if you plug it all in, and yes, all of your dollars and cents need to be rounded to dollars and cents, 2 decimal places. It will not tell you that. That is going to be what you will assume there. Compounding continuously. This is your next equation. Here it's A equals your principal times E raised to the RT. This is not a number of times a year because it says continuously. So you're going to do the same thing here. Account balance is what you're looking for. Investment times E raised to the 9%, again in decimal form, times 17. And you will need to pay attention to your calculator. Make sure you don't make a calculator error when you do this. For this one, you should get 38,487.89. All right, expanding. So remember your rules for expanding. When you are expanding something, your exponents become coefficients. If you have something that is multiplied, you expand with addition. If you are dividing you expand with subtraction. All right, so this is expanding. The first thing I'm going to do is rewrite the guy so that this becomes an exponent. So log base 4 of z times this whole group raised to the 1/2. I am going to expand this by addition. So I'm going to say log base 4 of z plus log base 4 of xy to the 1/2. All right. I am going to now move this exponent out. Log base 4 of z plus 1/2 log base 4 of xy. This multiplication can be expanded with addition. Log base 4 of z plus 1/2 log base 4 of x plus 1/2. That 1/2 goes to both of them, log base 4 of y. And I think in your answer key, they put it over 2. That's the same thing as 1/2 being in front. I'll take it either way. So I think your answer key looks like this, log base 4 of z plus log base 4 of x over 2 plus log base 4 of y over 2. I will take either one of those. I will say this, I will count off if you do not put your base of your log. That 4 must be on all of your logs when you expand, okay? Because technically you cannot condense if they're not the same base, all right? And so they should start it out as a base 4. They need to all end as a base 4. It's a really common mistake that people just forget that. So that is an error if you leave that off. All right. Condensing is this same thing. It just goes the opposite direction. Coefficients becomes exponents. Addition condenses to multiplication. Subtraction condenses to division. So usually I do all my exponents first. This guy is an exponent. That's what we just saw. It's the same thing as 1/2 being in front. So when I condense this, log base 3 of z, this denominator is technically a 1/2 times it. So I have log base 3 of x to the 1/2 and log base 3 of y to the 1/2, right? And then these all condense with multiplication. So I have log base 3 of z times x to the 1/2 times y to the 1/2. Anytime you have two with the same exponent, you can group them just like it did up there. You will notice something very similar about these two, right? They are the same thing, right? So, and remember 1/2 is a radical. So something to the 1/2 is the square root. So I'm going to say log base 3 of z and then square root of x, y. Which, by the way, this guy looks just like that guy, just a different base. All right.